Hello friends, in today's video we are going to talk about the batch oil adsorption tryout. So in the batch adsorption tryout, first of all let's understand what is the batch adsorption tryout or batch adsorption investigation. So basically batch adsorption tryout is done from the liquid phase. This is also known as immersion tryout, which is one of the most common tryout utilized to uh, compute adsorption equilibrium and kinetics from solution, or you can also say elucidations. And this comprises of the addition of a known mass of a sample, which is my adsorbent, to a fixed volume of liquid at an initial concentration. So here initial concentration means our target pollutant. And whereas the batch oil adsorption is a tryout that is used to remove specifically oil from the water by bringing closure the oil into contact with a solid material which is known as adsorbent in a closed shaped system or a agitated system. The oil molecules will attach to the surface of the adsorbent. So here the oil is my pollutant, or you can say the adsorbate to the adsorbent, effectively removing or eliminating him from the water or the liquid phase. This process as a whole is called, in broader terms, is called the wastewater treatment, or also called oil spill cleanup. Now in continuation, we all know that adsorption is a promising technology, okay, and this is widely used and also adopted as a practical method for eliminating organic contaminants from water, and this is because, or you can say owed, because of its high removal efficacy or efficiency or adsorption capacity and low operational energy and cost, and also it's widely acceptable because the materials that are used for adsorption are of low cost, mostly are low cost. Now in the description, this is the description of the whole batch adsorption process. So we will be mixing a known mass of adsorbent to a fixed volume. Usually in this process we will be using 40 ml of the oil emulsion water in a closed container, and we will shake it. Okay, this shaking will facilitate the adsorption process, and the oil molecules in the water are attracted to the surface of the adsorbent. So this whole process is known as adsorption. After a certain time, the mixture is segregated, and the remaining or the lingering, or you can say the remainder oil concentration of the water is computed. Now the influences that will affect the adsorption process are the adsorbent type, what is the adsorbent type, and what is the nature, the physical chemical properties, its surface area, porosity or permeability, okay, its functional group. And the second point is the dosage of the adsorbent, how it can affect if we put a large amount of dose of adsorbent or low, so how it can affect the adsorption process, the contact time. The longer the adsorbent and oil are in contact, so more oil will be adsorbed. This is a general phenomena. The temperature, we are doing at room temperature or high temperature. The oil concentration, of course it will affect, and the pH, if we are doing at very high acidic pH or very basic, I mean alkaline pH. Now how we would prepare the oil emulsion for the adsorption process or adsorption tryout. So here first of all we will be taking 100 ml of the distilled water, or you can say you can also take deionized water or double distilled water. In that we will be adding oil, so followed by adding, we will not to do this, we have to add 20 milligram of surfactant. So here I am taking sodium lauryl sulfate. You can also take SDS or other surfactant also that is available in the market. And then it will be stirred well, followed by adding 1 gram of the oil. So we are taking oil in terms of weight, okay, and which is the source of the hydrocarbon. So this is the filtered diesel oil, and this mixture will be shaked vigorously to ensure there is proper dispersion of the crude oil, followed by 30 minutes tonification. So this is as per literature to stabilize the emulsion so that there is a well homogeneous oil water mix, because we all know that oil is not miscible in water. So this SDS or surfactant will facilitate the mixing of oil with the water. The prepared emulsion should be transferred to a separating funnel and allowed to settle overnight to separate any free oil layer. If there is a free oil layer even after mixing with the oil and SDS, so this will ensure the homogeneity of the prepared final elucidation or solutions. Now if we look at the other papers also, if you see, this is the paper published in 2021. So here they have prepared the oil emulsion. We prepared a mixing gasoline oil with deionized water to mimic the behavior of oil water emulsion in a reservoir. This is common approach in upstream research for oil and water emulsion. The oil water emulsion will prepare dissolving 0.6 gram of surfactant with 1 liter of the deionized and mix in shear emulsifying homogenizer at a speed of 3500 rpm. So here I have used around 1000 rpm for overnight in my case, and this concentration of surfactant was found to be proper dosage that produces homogeneous. So I have taken 20 milligram. We can vary and check, I mean, which ratio gives a better bonding of oil with the water. This concentration of surfactant was found to be proper, that produce a homogeneous, or you can say well mixed or well dispersed according to the stability test performed. Subsequently, a specific concentration of the gasoline was added dropwise and mixed with water for 10 to 15 minutes to produce homogeneous oil water emulsion. So this is as per the paper. In my case, I have taken 20 milligram of the surfactant and 1 gram of the oil in 1 liter of the water. So the concentration of the oil in water here is 1 gram per liter, or you can say 1000 milligrams of the per liter. So this was all about. So shortly we'll see how to do the batch absorption test in the laboratory. Hello friends, in today's video we are going to do the batch adsorption of oil. Okay, so before going ahead, first of all we will prepare the oil emulsion. So for preparing the oil emulsion, we are going to add 1 gram of the oil, so in 1 liter. So here I am adding by a dropper. You can use a micro pipette. Now this is around 1 gram. Oil used here is diesel oil. This, as per the methodology, we will also add a surfactant so that the oil emulsion is well formed with the water, because as we all know that oil is not miscible with the water. Okay, oil does not mix with the water, it will keep floating on the water. We have added around 20 milligrams of the surfactant. So surfactant is sodium lauryl sulfate. Now you can see that after adding the oil and surfactant in water, so slowly it has started to mix. So usually it takes overnight to form an emulsion. This is my previously prepared emulsion. So you can see the solution is very turbid. So based on the turbidity, we check the oil and water removal. See that it started to mix with the water. So we will leave it overnight. Now we will check the turbidity of this solution before starting the batch adsorption, or if you are doing column adsorption also. So you have to check the turbidity of the prepared oil emulsion. Turbidity of the oil emulsion shows around 150 NTU. We are testing here 3 adsorbents. You can see one. This is the first one, second, third one, and then we will weigh around 5 milligram and transfer into these vials. For measuring, we will transfer into this vial. Transferring these vials, okay, the adsorbent, then we will transfer the prepared emulsion. Already the adsorbent is transferred to these vials. Okay, now we will shake it for 3 hours and then we will check the removal. So this vial has begun to shake. Okay, now after 3 hours we'll try to take out the samples and check the removal. So before this, what we have to do, we have to take off the sample, centrifuge it, and then check the removal. So we have added our vials, okay, and we will centrifuge. After centrifugation, the solution looks very clear. Now I have transferred the sample from the first vial. So this is LDH, and for the LDH, now I will check the turbidity. Here the turbidity shows around 80, and for the bead sample already transferred the solution, so we will check the turbidity. is around 111. Sample already have transferred, so here it shows 131. So this was all about the batch and oil adsorption. And in order to segregate the oil from the water, or you can say oil and adsorbent from the water, you can do centrifugation, you can also do filtration, okay, using vacuum filtration technique or a syringe filter, okay, and check the removal. So here our LDH performs better. And also if you want to calculate the adsorption capacity, so here this is 150, so it will be 150 minus 80.3, okay, C naught upon C naught minus CE into V. So volume here is 40 and the mass of adsorbent is 5. So we can, in terms of removal, it would be 150 minus 80.3 upon 150 into 100. Similarly, you can calculate for the third and the second. So this is all about the batch adsorption and the calculation of adsorption capacity. So here the QE unit will be, you know, that milligram per gram, and this will be in percentage, okay.